difficult to remember as last time because it'll be somewhat familiar. So it says, for this problem, it says 2 friends are trying to decide where to spend their spring break. One friend favors Chicago while the other favors Honolulu. Go to usclimatedata.com and fill in the monthly average high temperatures in the table below. So grab your phones, and we're going to go to usclimatedata.com. This website is nice. If you want to find average temperatures. So here's the average high and the average low over the year for Raleigh-Durham area. Okay. And then if you scroll down on your phones and go all the way down to the bottom, it'll give you a list of the states by name. What state is Chicago in? Illinois. So we're going to go to Illinois. And then you're going to scroll down and you're going to find Chicago. And then it'll give you a list of Chicago's temperatures. So we're going to take those temperatures and just fill them in the table. So January is a average high of 32. February is an average high of 34. March is an average high of 43. April, 55. May is 65. June is 75. July is 81. August is 79. September is 73. October 61, November is 47, and December is 36. Okay, so that's what you should have so far. And then it asks you to do the same for Honolulu. And the Honolulu data cracked me up. I want you guys to look it up because it made me laugh. Anybody have any predictions about Honolulu? They're all high. Mm-hmm. So I just went back when I did mine. Honolulu's in Hawaii. Also, look at these names. Aren't they fun? Except for Princeville. That one's not as fun. Barber's Point. Captain Cook. No? Nobody? Okay. Honolulu. You guys, look at those highs. It's literally in the 80s for the entire year. Isn't that wild? Okay, so we're going to write down the highs for Honolulu as well. Okay, so at this point, let's go ahead and let's start our regression. Does anyone remember how we plug in tables to start regression? We hit a button. Anyone remember? Anyone remember what button we start with? We start with the stat button, so we're going to hit stat. And it allows us to plug in a list. Now, for the months, January, February, March, April, May, June, we're going to have to plug in numbers. So let's do 1 through 12. That's pretty typical for these problems. Usually they tell you to do that. This one didn't. But usually they do tell you. Okay, so for to start with, we're only going to do Chicago. We're going to ignore the Honolulu data to start with. So I'm going to do stat first, edit, press enter, and for list 1, I'm just going to type in the months. So I'm just typing in 1 through 12. And then for list 2, I'm going to type in those corresponding high temperatures for each month. Being careful to make sure I don't have any typos. And we want to be able to see our points once we've gotten them plugged in. Do you guys remember how we get it so we can see our points? And Dalton, I need you to put that away so you're participating with what we're doing. Completely put it away, all in your bag. Thanks. So how do we get it so we can see these points? Say it again. Before the window, we have to do something with the graph. Do you guys remember? We hit y equals before stat plot. So we're going to do second y equals because we want to do stat plot. We want to turn it on so that we can see the points. So right now the stat plot is off. We want to turn this on. So I'm going to press on plot 1. I'm going to press enter. And I want this to be on so I can see the points. Plot 1 I want to be on. I want to see, and you can see the picture of it. It's a scatter plot. I want to see a scatter plot of the points that I just graphed. Okay? All right. And then I want the window to be correct. So I'm going to hit the zoom button. And if you guys remember, we go down to number 9, zoom stat. So it's going to use the information I plugged into the stat window. Remember when we plugged in, we hit stat, and that's where our lists were. So zoom stat is going to use the lists to figure out how far it should zoom in so that we can actually see those points. So zoom stat, press enter, and now we'll be able to actually see the points that we just plugged in. So we do stat plot and then zoom stat. Okay, can everyone see the points? Okay, what does this graph kind of look like? The Ferris wheel graphs, which were actually what kind of graphs? They were cosine graphs, right? And we know that cosine graphs and sine graphs are actually the same thing. If we were to graph the whole thing, it would be a wave. It would go up and down and up and down. And this is a graph about months of the year. So after December, it's going to go back to January. It's going to start all over again. And then it's going to go back to January, start all over again. So this graph would be a cyclic graph. It would go up and down, up and down, up and down. It would keep going, right? So when we write an equation for this, the equation could be a cosine equation or a sine equation. It doesn't matter. They're both kind of the same. If we were writing this from our own brains, we would probably do a cosine equation because that would be the easiest. Does that make sense? Okay. Now, the calculator is going to do it for us, though. We don't have to do it. And the calculator, when you do regression, the calculator always does sine. It's just going to do sine for you. Okay, so let's go ahead and figure out what the regression model is. So we're going to hit the stat button, and we're going to calculate. We're going to go over to calculate, and we're going to scroll down until we find sine regression. Now, the iterations, I don't know exactly what that means, but it sounds like it has to do with the accuracy. So the default is 3. The highest you can go is 16. And the higher you go with this, the longer it takes because the calculator is iterating more. I don't know. So I'd love for us to try different numbers with this and just see how different our answers are. My guess is some of the answers are going to be more accurate than others. But since we only write down 4 decimal places, I'm curious to know like how accurate it is. So a couple of us are going to do 3. Who wants to plug in like 6? Marvelous. You guys at the back table, you guys are going to plug in 6. What table wants to plug in 9? Marvelous. You guys are going to plug in 9. And then I'm going to have you guys plug in 12. And you guys are going to plug in 16. Marvelous. And then everybody else can plug in whatever they want. So I'm going to plug in 11 just because I want to see what 11 does. Okay. So we've got list 1, list 2. That's what we're using. The period of this graph, we can leave it blank. If you leave the period blank, the calculator will calculate what it thinks the period is for you, but we do know what the period of this function is. Does anyone know what the period is? Not 1, 12 months. Does that make sense? 12 months before it starts over again. So if you know the period of the graph, you should type that in. The period of the graph is 12. You should type that in if you know what it is. Okay? And the reason for that is that if you don't type it in, well, I'll show you guys. So everybody else type in 12. I'll show you guys. I'll do one where 12 is not typed in, and we'll see what the difference is. Okay, so we're going to store our equation. Does anyone remember where we want to store the equation? We want to store it into the y equals screen so that once we find the equation, it will graph it for us and we can compare it to our points. So the way that we get the y up there is we hit alpha trace. So if you do alpha trace, that gives you your y variables. And we're going to go ahead and just store it as y1. It doesn't really matter where you store it. So I'm going to store it as y1. And I'm going to go ahead and calculate. All right, so here's all of the values. My guess is since you guys plugged in 12 for the period and I did not, our B values are probably different. Are they different? Your B values are the same as mine? You guys plugged in 12 for the B? Everybody plugged in 12 for the B? Okay. All right, let's go ahead and write down the model. So I'm curious to know, because I used 11 and everybody used different numbers, are all of our numbers the same? So if I do my first number, my A value, and you can see this tells you where to plug all the numbers in. So A is the amplitude. So for mine, I got 24.7066, and I used an iteration of 11. Did anybody get something different than 24.7066? You guys got different? Which digit was different? Was it all 4 of them? And you guys had, what did you guys have, 12? 16? What did you guys get? Okay, so it makes a big difference. What did you guys get? You guys got the same thing? Okay, and oh, you guys plugged in 12, so that would make sense, because I plugged in 11. Okay, what did you guys get in the back?
No, we did 9.
You guys did 9? What did you guys plug in? 6, and you got 24.7066? Okay, and then what did you guys plug in? 12? Okay, so you guys would have got the same thing. Okay, so it made a difference with 16. Okay. So it seems like it did not make a difference. Is that what we're getting? Okay. All right. So we've got that. And then the next thing we write is the sign. So in the beginning, they'll always tell you where the variables go in the equation. So next we have sign. And then notice when they give you the regression model, they do not give it to you in factored form. They give it to you in the unfactored form. So you could not look at this regression model and tell how far the graph has shifted to the left or right. You can't tell from the regression model because it's not factored. Does that make sense? I can tell if it shifted to the left or right. I can tell that that happened, but I can't tell how much because it's not factored. Okay, so my B value for mine was 0.5132, and I got that when I think I did not plug the period into the graph, and you guys did plug in 12, right? And we all got the same number? Yeah? Oh, that's really interesting. Okay, I figured it'd be different. All right, and then next I got my C value, so I'm going to minus 2.1505. Did everyone get that same number? What'd you get at the end? 09, you said? So 2.1509? Okay. So I think what we probably could do is just leave the default iterations are 3, and I think we could just leave it at 3, since it doesn't seem to make a huge difference, and then that would be easier than just changing it every time. The number on the end is 56.2804. Okay, so there is our sine regression equation. And we can go ahead and graph this. How do you guys feel about how the model fits the data? Did it do a pretty good job? I feel like it's pretty good. Let me see. Do you have a typo in your data, maybe?
No, I think it's 3 already.
I think, so one of them I think might be a typo. Let's do edit. $55. Wait. Oh, you did 56 instead of 36.
I think I had that written on my paper too.
Okay. All right. Does anyone have any ideas on if we were to look at the graph, how could we find the average annual temperature? If you were to look at this picture, how could you find the average annual temperature? Add what together? All the numbers. Now all the numbers is not just the numbers on the table, because how many points show up in a line? Infinitely many.
So then just the 12.
But that's not all the data.
Then
You can't add all of them. Okay, so we can't do that because we'd be adding forever. Would it just be the amplitude? You're kind of close. What's the amplitude is the distance, right? Is the distance going to be an average? Is it the middle of that? So here's what I want you guys to discuss. At your tables, because I can feel that like 2 or 3 people care about this question and the rest of you guys stopped listening and started having side conversations. So I need you guys to figure out how to answer number 2. So go ahead and figure out how to answer number 2 in your tables. Ready, go. Discuss with your tables. How would you find the average annual temperature? So tell me, what is the average annual temperature? Okay, so somebody explain to me why it's 56. 56.2804. Why is that the average annual temperature? It's right in the middle of the graph. So if you look at the graph that we have the highest point up here. We have the lowest point down here. What is the middle of this graph? What's the name of the middle of this graph? It's the midline. And where can you find the midline? And you can find it in the middle. Where can you find it in the equation? At the end. So if this is the middle of the graph, it's also going to be the average number of the graph. Does that make sense? You don't have to do any computations for it. The calculator already did all the computations you need. So the average annual temperature is going to be 56.2804. 0.2804. It's just the midline of the equation. So we're going to say the average annual temperature is 56.2804 degrees. This is the midline of the equation. All right. Next, it says to graph the data points for Honolulu. So we're going to go back to stat. We are not going to get rid of this data. So I'm going to show you guys how you can graph two sets of data at the same time. So we're going to hit stat. And we're going to go back to edit. And this time we're going to go over to list 3 and type in the data for Honolulu. So 80, 80, 81. And we want the graph to, we want to graph this data again. We want these points to be plotted again. So we're going to hit stat plot again. So second stat plot. We're going to go to plot 2. And you're going to turn it on, but that's not all you're going to do. So we have to pay attention to what they're using to plot the information. And right now, they're using list 1 and list 2. If we use list 1 and list 2, it's just going to plot the information for Chicago again. So where did we plug in the information for Honolulu? List 3. So we're going to go down to the Y list. We still want to use list 1 because we still like the months. We still want to use January through December. But now we don't want to use list 2. We want to use list 3. List 3 is right above the 3 key. So look at your 3 key. Look above it. Do you see it in blue or green? Blue. So we need to hit second and then the 3 key. Second and then the 3 key. So now it says L3 there. So now we have the second plot on. It's going to use list 1 and list 3 to make the scatter plot. So now it's going to plot the points from list 1 and list 3. That's how it's going to get the X and the Y coordinates. Does that make sense? So we're turning it on. We're using X and Y coordinates from list 1 and list 3. Okay. You should still be good with the same zoom from before, so we don't really need to hit zoom stat again. We can just hit graph now. And then it looks like a couple of our points at the very top are cut off. And so what we can do is we can go ahead and hit zoom stat. So zoom number 9, and it will just fix the window a little bit for us based on the new data that we did. So the old window was just a little bit too small. When I did zoom stat that time, it just shifted everything down a little bit. Okay, does that make sense, what we just did? So that was an extra step in case you want to see both sets of data at the same time. You can always clear it and start over, but you don't have to. We can look at 2 sets at once. Okay, so we're going to get the model for this one, and we're going to go ahead and have everybody do the same thing. So let's go ahead and hit stat. We're going to go over to calculate. We're going to go down to sign regression. For iterations, you can just leave it at 3 since that didn't seem to make much difference. List 1, I don't want to do list 2. If I do list 2, that's going to get me Chicago again. So how do I get Honolulu? I'm going to do second, number 3. I want list 1 and list 3 so I can get Honolulu, not Chicago. For the period of the graph, you can leave it blank since it didn't seem to matter. I'm going to store this one. I'm not going to store this one as number 1 because I already used Y1. I'm going to store this as Y2 so that I can see 2 graphs at the same time. And then I'm going to go ahead and calculate. So is everyone okay with everything we plugged in? You do alpha trace. Okay, so we have y equals 4.6756. Is that what everyone got? Yes? And then for our b value, we got 0.51. 49 is followed by a 5. So 49 would round up to 50. Do you have any typos in your data? Did you check your data for typos? For what? 6754. Let me see. I did not. Did you guys put the period in?
No, I didn't.
Okay, so if you put the period in, you get a slightly different number? Okay. That's weird because it seems, I guess that could affect the A value, yeah. Did you get the same B value? Okay, and then for C, we've got minus 2.4538. That's really interesting. Okay. And then 84.43. It just means that when I grade them, I'll plug in the period and not plug in the period, and I'll have multiple options. I'll have them both written down. You have different than this? You have the same iterations? I wonder if that's just technology error then. That might just be technology error that we can't have 4 decimal places. No. Do not do that. Do not do that. I'll have to look into it more. I wonder if these are only accurate to like the first couple decimal places.
So do you want me to write mine or write yours?
This might be where the encouragement was for doing more iterations, actually. Let's all do, so everybody was saying that the first 2 decimals were the same, but it was like the second 2 decimals that were not the same? Okay, so let's go back and let's do the same thing, but we're going to do 16 iterations instead, and we'll see if we all have the same decimals then. So instead of doing 3, do 16. So this is what your screen should look like. And I want everyone to do it because I want to see if we get the same decimals to 4 decimal places. Yeah, don't put the period in for now. I want us all to have the same thing. So 16, L1, L3, Y2. Okay, has everyone typed it?
Yeah.
Okay, and let's see if we all have the same decimals this time. So 4.6755. Did everyone get 4.6755? Did everyone get these 4 decimals? You didn't get 0.55, the 55 at the end? Okay. For the B value, 0.5150. For the C value, negative 2.4543. And then for the end number, 84.4388. Okay, so let's always do the 16 for iterations because I think that helps with our accuracy as far as matching each other. Yeah, let's do 16. Yeah. Yeah. Okay, did everybody hear that? We're always going to do 16. Okay. What is the average annual temperature? Yeah. The average annual temperature is 84.4388 degrees. Okay. So the next question, don't shout it out. I'm going to have you guys discuss it in your groups. Which city has the greater variability in temperature throughout the year? And I want you to defend your answer using part of the model, part of the equation. So don't just tell me, well, duh, based on the table you can tell. I want you to say, based on the equation that we got, I can tell that this city has more variability in temperature because of this part of the equation. Okay, so looking at the equations, which city has more variability in temperature and where in the equation can you tell? Go ahead and discuss in your groups and we'll figure it out in a second. All right, what did you guys come up with? Okay, so Chicago's the duh answer, but what part of the equation tells you? The amplitude. Okay, so Chicago has more variability in temperature because it has the greater amplitude. All right. Spring break is the second week of April. Which city would be best? What's your criteria? Should other criteria be considered? So if we are going to figure out what the temperature is supposed to be during spring break using our equations, what number should we be plugging in? The second week of April. Okay, so we're going to plug in the t value, the value for the time. Should we plug in 4 exactly? Should we use a decimal? Is there a difference between like the first week of April versus the second versus the third? Five is May, 4 is April, 4.5. You guys want to use 4.5? It doesn't really matter because we don't have a numeric answer for the question, right? This is kind of an opinion-based question. So if you guys want to use 4, we can use 4. If you want to use 4.5, we can use 4.5. What would you guys rather do? 4.5? Okay, so I'm going to show you guys something in the calculator that's kind of cool. So our Y1 is Chicago. Our Y2 is Honolulu. So if you want to take Chicago's equation and plug in 4.5 to like evaluate Y1 with 4.5, you can literally type into the calculator Y1 evaluated at 4.5, and it will just plug in 4.5 for you, and you don't even have to like look at the graph or plug in 4.5 into the graphing screen. You can do it on the regular calculating screen. So what we're going to do is we're going to go to this normal calculating screen, and we're going to put Y1 on the screen because Y1 was Chicago. So I'm going to do alpha Y equals, or alpha trace. I'm going to get the Y1 up there, and then I'm going to tell the calculator to plug in 4.5 for Y1. So this is that function notation. It says Y1 of 4.5. Kind of like saying f of 4.5 or g of 4.5. I'm saying here's the function I want, plug in 4.5. And the calculator will do it, and this is the output. So 60.1876. So we knew that April was the 4th month, but it was the 2nd week in the 4th month, so we just said, let's give it a decimal that's kind of in the middle. Yeah. Honolulu is going to be Y2 of 4.5. So we're going to do alpha trace. We're going to get the Y2 and plug in 4.5. 83.8020. Okay. And now what I want you guys to do is write a couple sentences saying which city you think is best and what your criteria is. So is it merely the temperature? You think the temperature would be best? Is that the only criteria that should be considered? What do you guys think? This is an opinion question, so this is not a mathematical question. This is strictly your opinion. Which city would be best for spring break and why? This one says the table shows the number in millions of unemployed people in the labor force for 1984 to 1995. Here's the data. It says use a graphing calculator to graph the data points for unemployment using x equals 0 for 1980. So if x equals 0 is 1980, then what would 1994 be? If 0 is 1980, then what would 1994 be? It'd be what? If 0 is 1980, what would 1994 be? 4. Okay. 4, 5, 6, 7, 8. So we're not actually going to type the years in there. We're going to type how many years it's been since 1980. So how do we type the data? Where do we go? Stat. I'm going to hit the stat button. Edit the list. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And here we're going to be real careful about not getting typos. And how do I make it so I can see the points? Turn on the thing. How do I turn it on? Before Zoom 9. Second stat plot. Okay, so I'm going to turn this one on. Yeah, and now we know it's actually using list 1 and list 2. Because we only have a list 1 and list 2. Okay, and now I'm going to do Zoom 9. What do you guys notice about this graph? How is it different than the other two? Goes down and then back up. So what does that mean in terms of a sine or cosine curve? Say it again. It might be a sine graph, yeah. But we know that sine and cosine are interchangeable, right? They're each other. You could write it as one or the other. What's different about this one from the other ones? Looks like it could be shifted. To me, it looked like it could have a little bit more than one full period of the graph. Does that make sense? So the other ones had like one full period. It started down, it ended down. This one, it starts up, goes down, goes up, goes back down. Do you guys see how that's more than one full period of the graph? So you can kind of see multiple cycles of the graph, which makes sense because this is over a several year period that you're seeing a trend. Okay, it says to find the regression model. How do we do that? So stat, go over to calc, going down to sine. What do we change the iterations to? 16. We don't know the period of this one, so we can't plug that in. What are we going to store this as? Y1, so alpha trace. Plug the Y1 in. Yeah, I would just double check and see if you had a typo somewhere. Every time mine did something funky, it was because I typed something wrong. Yeah. So the A value I got was 1.2143. What did you guys get? 1.2143? Do you have a typo somewhere? Did you check to see if you had any typos? Sine. For B, I got 0.8049. Oops. Did we get 0.8049? Yeah. For C, I got 2.1193. And then for D, I got 7.7714. All right, what is the average number of unemployed people from 1984 to 1995? Okay. Did you do 16 for iterations? Okay, for the next part it says to use your model to predict how many people were unemployed in 1982 and 1996. So for 1982, what number would we plug in? 2. And for 1996, what number would we plug in? 16. So I'm going to go ahead and I'm going to get out of this. Well, I'm not in this. This is the regular calculating screen. So I'm going to do alpha trace. I'm going to pull up my Y1 and I'm going to plug in 2. And then I'm going to pull up my Y1 and I'm going to plug in 16. Plug in 2, plug in 16. Our model's kind of okay. It's not amazing, but... should you use your model to predict how many unemployed people there are in 2023? No. No, why not? Yeah, that data is pretty outdated. So we can use it to estimate something that's a little bit off of the data. 1982, 1996, that's not too far off. 2023, that's a lot of years off of the data, so it's probably not very accurate for estimations that far off. So for number 4, you're going to write something about the accuracy of models making predictions too far after the fact. We're not going to do that.